Hey guys, welcome to section 3, chapter 8 of the geometry program. In this section, we're going to be proving triangles similar. And in order for us to do that, we need several postulates / theorems, and they're going to look kind of familiar to you. So we used something similar, proving triangles congruent, but now we're proving them just similar. So the first postulate, and also the most common, is called the angle-angle similarity postulate. So it says that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So if we draw two triangles and we label them A, B, C, D, E, F, and we denote two sets of corresponding congruent angles, then that is enough to say that the triangles themselves are similar. So we would write a triangle similarity statement, something like this, D, E, F. Remember, just like when we were writing the triangle congruent statements, the order of the first doesn't matter. Just have to make sure that the order of the second is in the same corresponding position. Okay, so you're going to see AA a lot. But then you're also going to see something called side angle side similarity theorem, which says if an angle of one triangle is congruent to an angle of a second triangle, and the sides including the two angles are proportional, then the triangles are similar. So here we are again. We're going to have two triangles. Again, we'll have A, B, C, and D, E, F. And this one says if they have a set of congruent angles, and then if side AB is in proportional to DE, and that's the same thing as BC as in EF, then the triangles are similar. And we would write a similar statement. So ABC is similar to DEF. Okay, so that is the sides that form the included angle. All right, finally, the side-side-side similarity theorem. So if the corresponding sides of two triangles are proportional, then the triangles are similar. So that is just really nice and easy. You can grab any of the sides. We'll say X, Y, Z, and R, S, T. So if we say that XY is proportional to RS, and that is true for XZ on RT, and that's also true for YZ and ST, then these triangles are similar. So we would write triangle XYZ is similar to triangle RST. All right, so these examples I don't think are too bad at all for your homework tonight, so let's just jump in. First, they're going to ask you, can you decide if the triangles are similar? So you have to use some of the knowledge that we've learned over this course to apply and see if this is true. All right, in this picture, we see that we have a set of congruent angles. So we either need another angle, or we need the included sides. Well, they don't give us the included sides, so that one's out. But we do have another set of congruent angles, the vertical angles. So sometimes they're not always given, sometimes we need to infer this. But in this case, because now we have two sets of congruent angles, we can say that yes, the triangles are similar, and write a statement. So triangle ABX is similar to triangle CDX. Okay, so we had to just identify those vertical angles there. All right, what about something like this? We have two triangles. We have a set of congruent angles. So if we can prove that the sides are proportional, then we would be in good shape. So let's go ahead and set up a similarity ratio. So 6 is to 3 as 10 is to 4. And if we cross multiply, we're going to get 24 is equal to 30. But that's a huge problem because 24 doesn't actually equal 30. So these are not similar. If they had been in proportion, we could have said something like SAS, right? The similarity ratio of SAS, but they're not. Okay, moving on to our next one. All right, in this shape, we have actually a smaller triangle inside a larger triangle. If you notice that angle A is in both of them. So we have this small triangle, then we have this large triangle, and those are the two we're trying to identify if they are similar. So, all right, we have one piece down. They have an included angle that, of course, is congruent to itself. So now we have to decide if the sides are in proportion. So the sides of the smaller are easy to identify. They're simply 12 and 21. But in order for me to get the side of the larger, I have to add those together. So the sides of the larger are actually 20 and 35. All right, so now let's put our sides into a proportion. So 12 is to 20 as 21 is to 35. And let's go ahead and cross multiply. 12 times 35 is 420. And then 20 times 21 is also 420. Okay, so now we have sides in proportion and we have the included angle. So we can say yes, triangle ABC is similar to triangle ADE by the side angle side similarity. Okay, hopefully that's not too bad. I think, oh no, we got two more. All right, so let's look at this shape. All right, again, we can identify vertical angles are congruent. So we have a set of congruent angles. That's good. And we have two sides, sets of sides, I should say. So let's go ahead and set up a ratio here and see if they are congruent. So we would be careful. This side is actually corresponding to this side. So it's 15 is to 16. As 12 is to 24. And we're going to cross multiply and you're going to get 360 is equal to 192, which it's not. So these are not similar because remember they have to have both. All right, last one. Let's say they want you to solve for the variable and then also explain why the shapes are similar. So we can set up our proportions to check. Well, we're going to assume we know that they're similar. We have to say by how and to solve. So in order to solve for the unknown here, I have to set up a proportion. So x is going to be a corresponding side to 11. And then I'll choose these guys. So 10 is to 8. Again, remember you have to go in the right direction. I started with this triangle. This was my first, this was my second, so I have to make sure I stay in that order. Okay, and when I cross multiply, I get 8x equals 110. And x is going to equal 13.75, which makes us feel really weird that it's a decimal, but some of your answers are probably going to be decimals or fractions, so don't worry about that. So we've solved for that. We know that the sides are in proportion, so then how can we say that these two triangles are similar? Well, again, if we can identify the vertical angles are congruent and the sides are in proportion, so we have SAS similarity would make these two triangles similar. Okay, I think that that's probably all you need for this evening's assignment. So whenever you're ready, go ahead and finish up your notes, read through the examples, and begin your assignment.